In the last video, we learned how to create a pointer that points to a simple variable in C++. We also learned about pointer dereferencing and passing pointers to functions. Today, we will learn how to create a pointer to an array and learn about pointer arithmetic. In front of you, we have an array of 5 integers or 5 elements. Let's go ahead and create a pointer to this array. Because this array is an integer or stores integers, that means the pointer of this array must be of type integer. So I'll say int pointer ptr array like this. And what I'm going to say right here is the following. I'll say array. Now, what do you think this will do? You'll think that maybe this, when we write array like this, it will add or assign to the pointer variable, it will assign the address of the whole array or the full array. Well, that's not the case. When you write the name of the array and assign it to a pointer variable, what it will do is that this pointer variable right now contains the address of the first element inside this array. And the first element inside this array is 1. Let me prove it to you. If I say something like cout ptr array like this, and in another cout I'll say something like this. And this and right here is the reference operator. It is used to find the address of a simple variable. Like this, I'll say something like array index 0. And index 0 is the first element inside the array. And when we mention the reference operator, what it will do is that it will find the reference, or excuse me, the address of this element. Let's go ahead and see. So I'm going to compile my file and then launch this file. And as you can see, both of them have the same value or same address. Meaning, when you create a pointer of an array, you can either pass it this or you can pass it the following. And array index 0. Okay, so either way, you should know that when you create a pointer of an array, it will point to the first element inside the array. Now you'll tell me, what if I want to point to the next element, or the next element, which is 2, right? What should I do here? Well, this is where we will talk about pointer arithmetic. Let us say you have this array. Each element of this array is stored inside memory, and each element has their own address. Let us say the first address of this element is 3000, and the last element is at address 3016. Let us say you want to add 1 to the pointer. What will happen? The pointer now will point to the next element of the array. But how? Let's see why. Look at this equation. Can you understand it? Basically, the answer of this equation is 3004. At this address, there is the element at index 1, which is 2. So let's break it down. 3000 is the current address of the pointer. Plus 1 is the addition we are trying to perform. But we multiply 1 by 4, and 4 is the size in bytes of integers. And because this array stores integers, so basically each element has 4 bytes of space allocated. That is why you see that each address is 4 bytes away of each one. Let's go ahead and try to implement pointer arithmetic in our code. Let me go ahead and write this. ptr array plus equal to 1. That means I'm incrementing my pointer by 1. Now, let's go ahead and say cout like this. I'll say element at index 1 like this, and I'll say another cout like this. I'll say ptr array. I'm printing the address that is stored inside this array, but I want to show you that the address that we'll be displaying is the address of array or the element at index 1. So the element at index 1, we're getting its address by using the reference operator, and I want to show you that the ptr array now stores the address of the first, or excuse me, the second element at this array, which is at index 1. Let me prove it to you, and let's go ahead and after it explain the equation. So let's go ahead and see like this. As you can see, element at index 1. So yes, we are actually now pointing at element at index 1. So let's explain this equation again. So let's go ahead and take the example of the animation. So let's say the first address is 3000. And of course, pointer first points to the first element in the array. So basically the pointer right now is storing the address 3000. We add 1 to the address, and because this is an array of integers, we must multiply by 4. So first of all, 1 by 4 is 4, and all of this will equal to 3004. Okay, so right now we are pointing at the element at index 1, which is 2. So that is why we got the element at index 1. And let me go ahead and use pointer dereferencing. And when you dereference a pointer, that means you are accessing or fetching the value at this specific address. And let me show you that now we are accessing the element 2. Okay, let me show it to you again by compiling and launching my file. As you can see, element at index 1, it is 2, and 2 is at this address. Okay, now let's go ahead and say, for example, plus 2. Okay, now what will happen is that here we'll add 2, so 2 by 4 is 8, and so we will get 3008. Right now we will point at the third element inside the array, which is at index 2. Let me prove it to you again. As you can see, element at index 2, it's 3, and this is the address of 3. Now, of course, you can add the pointer as well as subtract the pointer. Look at this. I could say ptr array minus equal to 2, like this. And let me just put space right here. And look at this. What do you think right now we will get? I'll go ahead and say element at index. Well, I think we will get the element at index 0. And let me go ahead and say cout, and I'll dereference the pointer right now, and I'll say something like this again, and display the address of array index 0, or the element at index 0. Let's go ahead and see it first of all before explaining. Let's go ahead. As you can see, we got element at index 0, which is the number 1, and this is the address of 1. Now, why did this happen? Well, look at this. When you say plus equal to 2, that means you're adding 2 to the pointer and assigning the output of this addition. So basically right now our pointer stores like this, ptr array equal to 3008. This is what our pointer stores. But now when you subtract the pointer by 2, what you're basically saying is this: 3008 minus, like this, 2 by 4. So basically you're saying 3008 minus 8, which is 3000. Right now we're pointing at the first element of the array, which is element 1, which is at index 0. Okay, so this is pointer arithmetic in C++. Now that we know how to use pointers in arrays by manipulating pointers using pointer arithmetic, let me go ahead and introduce you to 3 more ways to print an array. The first way we know is this way. You use a for loop and use indexes to access each element inside the array. Now this notation, or this expression, whatever you want to call it, is called subscript notation. What we will do right now is learn 3 more ways to print elements of the array or from the array. Let's go ahead and start with pointer offset notation. I'll write it here as comment, pointer offset notation. This is what the notation is called. So what we'll do is you'll use a for loop, so int I equal to 0, I less than size of the array, like this, and I plus plus. What I'm going to do is I'm going to say cout, but what I'm going to do now is this. I'll write ptr array plus I, like this, and I'll say space like this. Now I'm going to say end-l right here, but first of all, let me show you what this will give us in the output. So I'll say something like this and like this. As you can see, we got a list of addresses. This is the address of the first element, the second element, the third element, the fourth and fifth, and so on. Okay, now we want to get elements. So what should we do here? Well, what you should do is you should dereference the address, or excuse me, the pointer. So I'm going to put all of this expression inside parentheses and dereference it. So when you dereference a pointer, what you'll get instead is you'll get the values. So let me show it to you. As you can see, this is the pointer offset notation. We got now elements, or elements at their specific indexes. Now what happened here exactly? Well, we use pointer arithmetic, and because I is changing at each iteration, well, first of all, I is 0. And let's go back to the previous example about 3000, where the address starts at 3000. So basically, because I starts with 0, that means 3000 plus 0 multiplied by 4. This one is equal to 3000. And at the address 3000, we have the first element, which is 1. So basically, you are dereferencing this pointer, which points to the first element, and what you will get is the number 1. Now at the next iteration, I will become 1. What we will say right here is I by 1 by 4, which this one should give us 3004, and now we're pointing at the next element, or an element at index 2. Okay, so this is how this notation actually works, and whatever we're doing here is actually pointer arithmetic. Okay, so I hope you understand this. Now let's go to the next one, which is called pointer offset with array name. So I'm going to say something like this: pointer offset with array name, like this. So again, let's use a for loop, int I equal to 0, I less than size, like this, and I plus plus. And now let's use pointer offset with array name. It's very simple and it's the same as this one, but the difference is that we're using the array name as pointer. So if I say array like this plus I, this is completely similar to this one. But what you're doing is that instead of using the pointer variable, you're using the array. So think of the array name right now as the pointer. Okay, so and you can use pointer arithmetic in order to jump from an element to another. So this right here is similar to this one. What's the difference? We're simply using the array name instead of the pointer variable. That's it. This is it. This is pointer offset with array name. Very simple. Okay, now let's go ahead and use pointer subscript. Pointer subscript is the most common way to actually print element from the array using pointers. Okay, and you'll use it all the time. Let me go ahead and show it to you. It's very simple. It is similar to the subscript notation. Let's go ahead and see it. So I'll say a normal for loop again, but now what I'll say is this. I'll say cout like this, and I'll say ptr array index I. Very simple. Okay, so what you're doing here is that you're using the pointer to access each element from the array, because I is changing at each iteration. At first it will be 0, so ptr array at index 0 will be the element at index 1 at index 0, which is the first element, which is 1. Okay, so this is very simple and it's very similar to the subscript notation right here. And when you're working with pointers and arrays and pointing and creating pointers that point to an array, you'll definitely use this all the time. And of course, you can use these notations actually to change an element inside an array. Like I could say something like this actually. I could use the pointer offset notation, which is ptr array like this plus 1 for example, and change the value at this position. I could say 13. So if I say cout like this and I say ptr, or let me use now the pointer subscript notation like this, so ptr array at index 1 like this, and let me show you also a before and after. So I'll go ahead and say something like this. Okay, let me go ahead and run my code. Let me show you that we could actually change or override the value using these notations. As you can see, we had 2 at index 1, and using either one of those 4 notations, we could actually affect the value of the array using either one of those 4 notations. Now, it's better, of course, to know all of these notations, but definitely when you will write code, you will mostly use the pointer subscript notation. Let me write it here as comments. So you'll be using this most of the times, and of course, as a C++ developer, you should know all of those 4 notations eventually. And this is it about pointers to arrays and pointer arithmetic. I know it can be dense at first, but give it some time and practice. Now, thank you for watching today's lesson. Make sure to subscribe to stay up to date for the next lesson. Now, I invite you to click on one of these end screens that will appear right now, and I hope to see you in the next video.